Hello. Oh, is this thing on?
It is.
So after this session will be our wrap up with the vendors and raffles in the Paradise Conference Hall. So I'd like to introduce you to Jared Swanson, a sales engineer at Avigilon. He's a sales engineer in Northern California, Nevada, Hawaii. He's got 20 plus years industry experience, 17 years with Integration Partner, 4 years with Avigilon, MSI, specialized in video security access control solutions for all regional verticals, 15 plus years of IT experience, and I am with the Nevada Department of Corrections. We are currently doing a proof of concept with them at one of our facilities in Carson with our existing surveillance equipment. So we're very excited about that.
Awesome. Thank you, Lisa. Well, good afternoon, everybody. Thank you for attending the track today. As Lisa mentioned, my name is Jared Swanson. I'm going to go through a couple of quick agenda items here. And really, what are we going to be talking about today? First part of this is we're going to talk a little bit about artificial intelligence as it relates to security and security protocols and things like that. We're going to be diving pretty heavily into unified security platforms versus integrated security platforms. And then I do want to talk about what does the future hold for our industry. So as Lisa mentioned, here's my really cool bio. She didn't talk about the last two things here. I am a self-proclaimed nerd. I do love all things technology, all things fun. I suck at PowerPoint. This presentation is probably terrible, but hopefully I get through to you guys, what we really need to talk about today. Funny enough, this little phrase down here at the bottom of the page, I wrote that at 17 years old. And it's kind of one of the things that I've used in both in my personal and professional career, just to kind of keep myself grounded in everything that we do, because we're always looking for the next best thing. We're always looking for the things that keep us, safe and secure. And obviously, being a security professional, it's really one of the things I have to deal with. So, with that being said, you've been to some tracks today where they probably actually talked about artificial intelligence. Many of you in the room may already have some experience with AI, whether that's AI on your phone or your refrigerator or any of the systems and things like that you use. I'm going to try to stay, pretty high level on this, but I did want to explain as it relates to the security industry that I'm involved in, really what does AI mean? And there's three kind of major concepts here. One, artificial intelligence, AI. What is that? It's basically the simulation of human intelligence in systems, right? Whether that's a computer system, whether that's hardware, whether that's some sort of device. And the goal of that device is to mimic human topology, right? We're trying to get computers to start thinking like we do. Perfect example of that, everybody's got a cell phone here, right? You've got AI technology in your cell phone, right? To enhance photos after you take them, right? You pull up your phone and you're pointing it at a plate of food and the little food icon shows up because the phone knows, hey, I'm gonna use artificial intelligence to make this meal look as fantastic as I possibly can. There's two parts of artificial intelligence that we really do focus on. One of them being machine data learning. Essentially, these are the algorithms that artificial intelligence use to interpret data and turn them into that artificial intelligence, right? So this is the first part of AI. This is where we're teaching, right? We're telling a system, hey, you have a certain set of data points, and I want to take those data points and I want you to turn them into, as closely as you possibly can, a human thought, right? And we know that as of today, computers don't think like humans yet, but through things like machine data learning and the more data that we can give systems, we're starting to experience things that allow AI to really shine, especially in the security industry. The other part of AI that my company really does focus on is convolutional neural networks. That's a really big word, and I actually really hate saying it because it's really hard to say. But essentially, when we start seeing things utilizing machine data learning, we can also apply them to other devices to learn from each other, right? So convolutional neural networks takes machine data learning from a base set of data points and then turns them into multiple systems that are now learning from each other. So this is typically applied when we're talking about cameras, right? Or security systems that need to learn about their scene or need to learn what is in that scene. So CNN, or convolutional neural networks, is a great way to take information from visual imagery and then apply analytics to them or apply artificial intelligence to those. So we did talk about this a little bit. I'm gonna go into it a little bit deeper here. So AI is everywhere, right? We talked, I kind of said, hey, you have AI on your phone. You probably have AI in a lot of things that you may not really even realize. But really, the goal of artificial intelligence as a whole is to take a system and really try to ensure that it follows human topology as much as possible. This is not the idea that, hey, every computer system is going to think like a human or be a brain. It really is training them to anticipate items or anticipate things and then be able to automatically respond to them using the technology that we give them. Machine data learning, once again, this is where we start, right? We're teaching our systems to learn. So if you think about machine data learning, essentially, machine data learning is an infant, right? Anywhere between 0 and 3 years. When we talk about children in that fashion, they're influenced by the things around them, their parents, their environment, the things that are going on to start to learn what things are, right? A baby out of the womb does not know the difference between a hand and a foot or a rattle and a cradle. However, over time, the more that we teach them these items or these icons or these objects, which you're going to hear me say quite a lot, they start to learn what those things are, okay? But this has a limitation, right? Machine data learning as it stands today in the security industry does kind of have a limitation. We can only teach them so much. We give devices a certain set of data points to start from, and then we need them to kind of take off and learn on their own. And that's where CNN comes back into play. So if we have to kind of quantify or classify CNN, convolutional neural networks are your 3-year-olds through your teenagers, right? They start learning on their own. They start understanding what their scenes are. They start understanding what is usual and what is unusual. And they take that initial data set and they turn it into more information. So they're going to take that information and they're going to give you a situational outcome based on that base set of information along with what it's learned along the way. So this is a very kind of high level overview of what AI and a couple of the individual technologies is really about. And honestly, this is the direction as we kind of talk into the future that we're starting to see in so many devices, right? We have AI-enabled Wi-Fi, right? That can anticipate things like overages. We've got too many people connecting to a network. Maybe we need to open up additional channels, and the Wi-Fi network can do that on its own. Doesn't need any interference from IT or anyone else. These are the types of things that we're starting to see alongside all of our industries. I'm going to try to stay focused on the security industry. And this is one of the things that we do talk about here when we talk about AI as far as device-based or edge-based versus server-based. So in an edge-based or device-based, essentially the device at the end of the cable has the intelligence, right? It's the device that has been trained with that machine data learning to understand the difference between people and vehicles, right? Or background and foreground, or what is in the background or foreground. And the intelligence is at the edge, and it uses metadata to take that information and then it sends it to a system to be parsed or done with, right? There's something that we can do with that information based on what that camera knows or learns or that device knows or learns. Server-based AI is essentially, I have a device at the edge that's kind of dumb. All it's doing is looking at something or interpreting information, and then we're using server-based or we're using GPU-based, graphical processing-based AI to impart data on that stream in transit or at rest. What's great about either one of these is they give you a similar outcome. Now, edge-based AI is extremely efficient because I can slap a camera up or I can put a device on the outside of the building and it's already got all of the intelligence, and I just need a system that can take that intelligence and do something with it, right? Server-based AI is extremely important because what if I do have an older device that doesn't have those capabilities, but I want to be able to add that information to that? If you guys look up in the ceiling here, I guarantee you none of these cameras have any AI capabilities, right? Either they're analog or they're regular 1080p cameras that don't have that capability. With server-based AI or GPU-based AI, we could essentially add classified object analytics or line crossing or any of those features that really allow security systems to do more than just record a scene, right? That's really the outcome that we're looking for when we talk about AI as it refers to security. So let's segue just a little bit here, guys. So I'm going to use two different terms here. One, you guys have probably seen things like this all over, Twitter, LinkedIn, things like that. And some of you in your facilities may have things that look like this, right? And that's okay. It's all right. But essentially, what I'm starting with here is disparate security solutions, right? Disparity in our security solutions is not the end of the world, right? And the reason that that's not the end of the world is someone spent money on this stuff, right? Even these 7 cameras or 7 cameras sitting next to each other serve a purpose. There's something that they're doing. That video wall has a purpose. That really, really bad network rack with all that fiber sitting there, it has a purpose. But is it efficient? Is it providing the outcomes as a customer, as an end user, as an integrator, as a partner that you want? Or are you just having to deal with it? In most cases, you're just having to deal with it. Now, this is where integration versus unification comes into play. Now, I am going to kind of read this line by line. The definition of integration, because this is important. The act or process or an instance of integrating. The example that I love to give with integration, and by the way, I don't hate integration, I actually love integration. But the example that I love to give with integration is square peg, round hole, okay? And if I go get a bandsaw or a jigsaw or a belt sander, I can fit a square peg into a round hole. That's integration, right? Integration typically takes a lot of time. Typically, it takes a ton of carnal knowledge about the systems that you're trying to integrate. A great example of this is an access control system integrating into a video management system, right? I've got XYZ manufacturer and XYZ manufacturer, and maybe I have an API. Maybe it's REST. Maybe I have a .NET SDK, software developer kit. Well, that's great. If someone is smart enough in this room to actually figure out how to get A to talk to B, I commend you. But what happens when manufacturer B goes, hey, we're not using .NET SDK anymore, we're using C++, or hey, we're gonna switch everything to REST commands through an API. You either have to rebuild that integration or you have to relearn how to integrate those things together and hope and pray it works. Now, there's a couple different ways of doing integration. Obviously, there is software-based integration, which is literally, we're using APIs, we're using SDKs. There's hardware-based integration. I know it doesn't seem like it, but I/O, inputs and outputs, whether they're digital or physical, wiring from a device to another device is actually technically integration, but it takes a long time. Or it takes a lot of money because you're typically wiring that, you're physically installing it, there's something going on there. So, unification. The act, process, or result of unifying, the state of being unified. Now, unification, if you look at the definitions, they don't look that much different. The biggest difference there is that word result. Because in a unified system, and it doesn't have to be from the same manufacturer, but in a unified system, everything talks to each other using common languages, right? Unification still uses things like SDKs or APIs or whatever the programming language is, but it's typically controlled by the same company or the same language, right? So everything is common. As a programmer, which I am not, trust me guys, I hate writing code. As a programmer, I only need to know one thing. I need to know at the end of what I'm trying to do, starting at the beginning, all of the things being unified together will give me the outcome at the end of the day. So using an API, whether that's REST or JSON commands or XML or whatever it is, when I start with an idea, I get an outcome. And it becomes very simple. That's really where unification or unifying systems together is more effective, more efficient than integrating. That's really all I'm trying to say with that. So in an end-to-end portfolio, you have things like this. You have fixed video surveillance, you have access control, you have body-worn cameras, you have video analytics, you've got AI, you've got all of these things. Now, whether it's from a single manufacturer, and don't worry about that. Whether it's from a single manufacturer or multiple manufacturers, having common languages and being able to unify your platforms together allows you to have outcomes at the end of the day using AI and technologies like that, so that you get these types of bullet points, right? Smart cameras, cameras that know the difference between a person and a vehicle. Access control that's open. It's not proprietary to a specific manufacturer. It uses common language to communicate to different systems. Whether it's in-car video, where it automatically is offloading that information when the vehicle comes back into the port, if you guys are law enforcement. Video analytics and applications regarding that. Object recognition, things like people, vehicles, license plates, faces, right? Facial recognition, we're gonna talk about that a little bit here too. But really tying these all together with a unified platform, at the end of the day, once again, gives you the ability to have an efficient and effective system, not a system that you're constantly worried that something may break or something might work. Now, these are kind of the 4 pillars of what we believe, or I believe, a unified technology system should really be able to do. Detect, that's the easy one. Analyze, a little harder. Communicate and respond. And one of the things I will mention is communicate and respond, you can flip those, right? Because sometimes I need to respond before I communicate. Sometimes I need to communicate before I respond. But detection's easy, right? Cameras. Every single one of you guys has a camera somewhere, right? That's easy. A camera looking at a scene. That's the detection part. Now, analyzing what's in that scene, whether it's using AI, edge-based or server-based, or it's using some other object detection. Maybe that's a sensor, maybe that's a red beam detector or a PIR or whatever it is. But using analyzation to give that camera, that device, intelligence, now it effectively gives me outcomes. Once again, at the end of the day, we're looking for outcomes. I don't want to have to go back and always be reactive in my systems. Detecting and analyzing allow you to be proactive. Well, communicate and respond, those are my end results. It really is up to you as the end user to say, what do I need my system to do after it's done the detection and the analyze part, right? I want to detect people jumping over a fence, and when that happens, I want it to send a notification via email. I know, Lisa, you're laughing at this one. I want it to send an email to somebody, or I want it to pop up on a screen, and I want it to play over my radio network, or I want it to call my cell phone. I want it to do something, right? I don't want to get caught up in the things that we can do, because every system can do something. But these are the kind of the 4 pillars that we talk about in a unified platform, being able to start from left and end up at the right. Once again, these are just some of the things that we talk about when we have a unified platform. Mobile, fixed, body, real-time crime centers, incident management. All of these things working together to give you the end result. So whether this is all from one manufacturer or multiple manufacturers, as long as you're using open platforms, that you're using unified technology, it doesn't matter what you have. They can all work together. Now, AI solutions, really these are the things that we look at when it comes to AI at the edge or those server-based devices. It starts with a classified object. So we're going to take a step right back to machine data learning, right? We started with that. Machine data learning is what we told the camera to start with. People and vehicles. That's it, right? Now, AI and using CNN can say that is a person wearing a gray top, a gray bottom, male, in his 40s, right? And he's got dark hair and he's wearing glasses. That's what AI is able to do. We take AI and then we can use it for things like facial recognition. We take it one step further. We have a camera that captures enough detail on a face to get enough data points to determine that that person is who we think it is. Okay, whether that's done manually or whether that's done automatically, I leave that up to you. Personally, I don't like automatic facial recognition. I like an operator having the ability to say, I'm looking for that guy. And I'm going to upload his picture to my system so that I can find him later, because that's important to me. If I see that guy come on my facility, I don't want to have to see him. I want the system to tell me he's on my facility. I don't want to have to do it. Do it for me. So this is where we start to see using AI to really punch in on the things that are important to you as customers and you as end users. License plate recognition is another perfect example of that. These are easy, right? All we're doing is reading characters on a license plate. Once we get that confidence that, hey, it is this guy, what do you want to do with that information? Do I want to notify the police? Do I want to send an email? Do I want to dispatch a drone to go fly over their car? I mean, you're looking at me like that. So these are the types of things that we start to see as we power devices with AI. I'm going to give you a couple of use cases here. Public safety. Basically, in a public safety environment, we're talking police, LEOs, sheriffs, even probably down to the DOC and things like that. Really, a unified platform enables a complete solution of technology to provide that outcome, right? Whether it's a glass break over on the left pane there that triggers an RTCC, a real-time crime center, to get a notification, and maybe they're dispatching over a radio network to a police vehicle that's in the area, okay? We're being proactive using AI because we got some sort of information, whether that was from a camera or for a sensor or whatever it was, and then we go through this entire process. And even at the end of that, right, we're trying to be as proactive as possible, but we know that there's going to be reactive stuff as well. Even at the end of this, I can use that data to go back and find things later. That's another part of AI, right? We use AI to be proactive, but I'm still getting all that data, so why don't I use it to go search for somebody, right? I'm going to search for the guy wearing a red shirt and blue pants, or I'm going to search for the face that I uploaded to my system. Detention centers, line crossing, beam crossing, people dropping stuff over the fence. These are all things that we use AI to create those outcomes. So you see how you can take each one of these and then enable your system to give you that information in the end. Safe schools. I am passionate about keeping schools safe. I have a 19-year-old son, I have a 15-year-old daughter at high school. We've had all of the issues that you actually see up here, and I know it's kind of hard to see. We've actually had all of these at my daughter's high school. We had an active shooter. Luckily, we caught it before anything bad happened. Obviously, bullying happens every day. Perimeter alert. Funny story. We had a cougar on our high school campus. Just came walking down the side of the hill and just walked through the campus and then left. We've had all of these things. And I'm unfortunate to say that my daughter's school doesn't use the platform that I represent. However, they do use a very highly recommended platform, and a lot of these things have been mitigated because they have a unified system. As much as I would love them to have my system, it's okay. All right, that's where it gets fun, guys. Because we were talking about AI, I figured this would be kind of funny. This is one of the things that people think about when we talk about artificial intelligence, right? Skynet. God. By the way, Terminator 2, one of the greatest movies of all time. So, really, what does the future hold? Well, one of the things we first have to ask is, what are people asking for? Also, really, what are unified systems looking like in the future? How are we going to enhance AI? How are we going to eliminate video walls? I was hoping there might be a casino person in here or two. How are we getting deeper into facial recognition and then balancing the need for all of this stuff? So, my company actually did a survey recently called the Consensus for Change Report. And there were actually some very striking results that came of this. Now, we all have to be very honest with ourselves that the pandemic and everything that's gone on over the last 24 months, I've done my best to not talk about that, by the way, but everything that we've had to deal with over the last 24 months has really affected the way that we look at security today. And we wanted to know, we wanted data, we wanted information from the people that are actually purchasing our products or purchasing security products in general. Hey, what do you think? An overwhelming 88% of citizens globally want to see their public safety transformed through the use of advanced technology. That's not just security cameras, that's everything we've been talking about today. That's advanced technology. 71% say they want advanced technologies such as cameras, data analytics, cybersecurity in the cloud, and we need these things to address our challenges that we face today and into the future. 70% say emergency services should be able to predict a risk, proactivity, and that can be supported by those advanced technologies. And then lastly, 75% of the people polled said that they are willing to trust the organizations that hold their information so long as they use it appropriately. That is very important, right? We all give information in our daily lives, right? Whether you're buying something, whether you're on Facebook, I know that was a big deal yesterday, right? It doesn't matter. Data is floating around the world all day, every day. And as long as people are using it ethically and correctly, it is okay. So, unified management solutions. Really, what does the future look like? I pulled this quick quote because, truthfully, unified management and the cloud, I haven't talked a ton about the cloud today, but unified management and the cloud end up being one in the same or hand in hand, right? We're starting to see more things moving to the cloud, or at least becoming cloud enabled or cloud focused or cloud centric, because we know that the cloud is here today. It is a great way for us to get, share, and retrieve information, and we know that it's not going anywhere. So we need to utilize it in efficient ways to make sure that our future is as effective as possible. So, eliminating video walls. This is kind of a touchy topic. One of the things that I've seen a lot, I do work with a lot of casino customers. I do work with a lot of real-time crime centers as well. You see this all the time. People looking at screens. That's really hard. It really is. If there are any casino guys in the room, hand, anybody? Cool. So if you've ever been into a casino surveillance room, it looks a lot like this picture here or even that picture there. There are tens, 50, hundreds of cameras up on a screen, and you are literally watching video all day long. It becomes very difficult. I didn't put the exact number up here, but I was once told it's about 15 minutes that you can actively look at a series of screens, watching video, and stay focused on the task at hand. Your eyes, your brain, your body just becomes exhausted with trying to process information. So one of the ways that we try to eliminate video walls is to turn the information into data. So instead of it being hundreds of cameras, why can't it just be hundreds of icons? Okay? In this example, and yes, this is a clip from my system, in this example, we use hexagons. It doesn't have to be hexagons. Maybe it's just little red dots. Maybe it's little squares. It doesn't matter to me. But color coding information that's important to you and then giving you the ability as an operator to define what you want to look at becomes way less stressful on the human body and makes you a more effective operator. That's important. We want people to be efficient. We want systems to be effective. And in this example, gray means the thing's online, blue means it's recording, teal with a blue border is a little analytic event, so something I've told the system I'm looking for. Yellow could be a facial recognition or an unusual activity event. And then obviously the most important one, because anytime we see red, we immediately respond with emergency, is red. So you have the ability to classify the things that are important to you so that you can identify them and respond and then communicate based on what's important to you. So what else does this future hold? These are the things that I see in some of the research that I've done that really do kind of bring us forward. So one of the first things, individually configuring options for the categorization of objects. Kind of a long-winded sentence there, but essentially what I mean by that is we need to go beyond people and vehicles. There are systems out there that are already doing that, right? There's the ability to detect make and model of vehicles, sometimes even year, based on a specific criteria. But same thing with people. We need to be able to classify people more granularly, right? So that I can look for a person wearing glasses, right? I need those types of, details so that I can effectively search for things in the future or use them as proactive tools. So obviously, next thing there, narrowing vehicle identification, not just classification of size versus, is it a car, is it a bus, is it a bicycle, but really being able to classify based on what an object is, not what an object looks like. Further classifications of objects held or worn by people, right? This isn't just weapons, right? This is things like backpacks. This is canes or anything that might be able to cause a slip and fall or carry something into a building. We need to be able to classify what people are wearing or what they have on their body. Am I wearing glasses? Do you have a hat? Do you have your mask on or not? Hopefully we don't have to have those too much longer, but that's another thing. Behavioral detections. This is a little controversial, but being able to determine if a person is being aggressive. Think about a crowd of people and you start to see that entire crowd of people moving quickly away from an area, or one person in a crowd of people throw a punch. So aggressive behavior, things that give unusual activity to a scene. Unauthorized object in an area detection. So this goes beyond just a person or a vehicle. This could be, hey, I'm totally fine with a car being parked here, but I don't want a forklift there, or I don't want a scissor lift, or I don't want something there, right? Or I don't want a drone flying over my facility. Brandish and concealed weapons. We have to be able to detect weapons accurately. this will keep all facilities safe. So right now, concealed weapons detection is actually a very, very popular item, right? Being able to detect not just via metal that someone is carrying a weapon into a facility, but a weapon in a backpack, or a person has removed a weapon from a backpack or their belt or whatever in a situation where we can see that using video analytics. Surface change detections. Did someone drop some water on the ground and then have a slip and fall? Or did it start raining and the conditions changed and then we had an accident? Being able to detect things based on environmental conditions. Pattern-based analytics for data metrics. So being able to actually start to create or start to learn patterns of people or objects. So this is kind of a retail application. The retail industry has been using this for years, actually being able to monitor people as they walk through a facility or through a store to say, hey, people keep walking this way and not going to this counter. We want to make sure that we get them going here. I want to see that actually expanded further, not just for data metrics for retail applications, but really for adjustments to floor plans, adjustments to social distancing, right? There's a lot of things that pattern-based analytics can start to help us with. Location-based anomaly detection. Essentially, if we're seeing anomalous events in a specific location often over time, we need to be able to detect that accurately. And then the last one here, open platform analytic engines. Right now, the majority of AI is proprietary, right? Whether it's my company, company XYZ, company ABC, we're all developing our own analytic patterns, our own analytics, our own AI. There's not a ton of open to that. And I am the first to admit, I wish that would change, because I think that having that unified platform that I continue to talk about really does require the ability for us to use open platform engines, not just what's on the edge or what's on the server. We need to be able to have systems talk to each other. So the next steps. We really need to be able to embrace non-traditional, right? Technology today is moving just as fast or faster than we've ever, imagined. And we do need these three things at the core to work together to protect us. And when those three things do work together, this is what we get. We get a unified solution, we get an effective solution, we get the outcomes that you all look for in these types of systems. You're not just getting the disparate cameras all over the place with the crazy server room and the speaker that's hanging off the wall. You're getting a unified solution that ensures your company, your employees, your customers, everyone is protected and safe. Thank you guys. I appreciate the time.